In our last video, we looked at quadratic applications where we set up a problem, set up a model using a formula, and we ended up with a quadratic equation, and then we could just solve for x, the unknown quantity in the application. In this video, we're going to look at some quadratic applications where we're looking at actually a function. And what we're trying to do is find the value of x that gives us the maximum or the minimum value of that function. So we need to remember that if we have a function that is a quadratic function, and we graph that function, if the coefficient here is a positive number greater than 0, we know that our parabola will open upwards. And we're going to have a minimum value right here at our vertex. If we have a parabola where a is less than 0, negative number, we know that our parabola opens downwards, and we're going to have a maximum at our vertex. But in both cases, it is the vertex. So the lowest possible value that the function takes on, or the highest possible value that the function takes on, is the y-coordinate of the vertex. So we're going to end up having to use our vertex formula. And remember, the x-coordinate is negative b over 2a, and then to find the y-coordinate, we plug negative b over 2a into the given function to find what y is equal to. So we're going to see that we can use that concept. We can use what we know about the vertex of a parabola to solve applications. Let's say that we have a wall, a long wall, and we have 200 feet of fencing available. And we want to build a rectangular storage area. And we're not going to worry about the gate or anything like that. We're just going to say that it's all completely fenced in. So we have 200 feet of fencing available to build a rectangular storage area. What should the dimensions of the storage area be to maximize the area? So on this problem, what we're doing is we're building a storage area out here against the wall. The fourth edge is created by the wall of the building. So this area this length that we have here is the fencing. So we have 200 feet of fence total, all the way around. And what we're trying to do is figure out what the area of that pen should be. So let's call this x, and since this is a rectangle, this is also x, and this other side here would be y. So we know that the length of that fencing, there's two pieces that are x and one piece that's y. So we know that 2x plus y is going to equal 200. What we're trying to do here is maximize area. Maximize area. The area of the pen will change depending upon what our sides look like, how long our sides are. If you use a little bit of imagination here, you could see that the length around here would all be 200 feet, but the area inside is going to change depending upon how you build the fence. So what we're trying to do is maximize, find the largest possible area within. So we need an area formula. And remember the area formula is length times width. I called them x and y, so my area is x and y. But x and y are going to change depending upon how I build the fence. So the area will change. So that means the area is actually a function in terms of x and y. I need to get this as a function in terms of one variable. So what I'm going to do is right here, I'm going to solve for y in terms of x. And I can do that by just subtracting the 2x. So I see that my y here is 200 minus 2x for the area of the length all the way around to be 200 total. So my area function, a of x, instead of x times L, or x times y, is going to be x times what y is equal to, 200 minus 2x. So a of x is equal to 200x minus 2x squared. So this is a formula, a function, that tells me what the area inside the pen will be if x is a certain length. And it changes as x changes. Now let's look back at our problem here. What we were trying to do was maximize my area. And notice what I have here is a quadratic function. If I rewrote this in standard form, putting the x squared first, I would have minus 2x squared plus 200x. Notice I have a minus right here. So that means that the area is going to be a downward facing, this should connect right here, downward facing parabola. This is my area for any length x, and the maximum value of x, the maximum area, the maximum value of y is going to be at the vertex. So when it says find the maximum area, that is literally saying find the y coordinate of the vertex, which means that we're going to use our vertex formula, negative b over 2a. This is going to give us my x. And then I'm going to plug that into the function, and that's going to give me my area. So I want you to see if you can do that. I want you to look at this quadratic function, and I want you to find the x value by using negative b over 2a, and then I want you to actually find the area by plugging into the area formula that we have right here. Pause the video, do that work, and then come back to the video. Okay, so we're looking at our function here. A is the coefficient of x squared. So a is equal to negative 2. B is the coefficient of x. So b equals 200. So negative b over 2a is negative 200 over 2 times negative 2. Negative 200 over negative 4, which is 50. Now this 50 is the length of this side here, 50 feet. That is not the area. The problem asked me to find the dimensions of the storage area, and I guess I also want to know what is the maximum area. So X is one side of the storage unit, the storage area, and then I can find the other side by plugging back into my formula here to find the length of the other side. So the storage area is 100 feet by 50 feet. Those are the dimensions. And if I want to find the area, I can plug back into the function here, or I can just use what I know about length times width and multiply 50 times 100. Let's see, 1, 2, 3 zeros. So the area is 5,000 feet squared. The thing to remember here is once we have a function that is a quadratic, to find a maximum, we're using the vertex. We can also find a minimum value using the vertex. Let's look at another example. Let's say that I'm going to throw a rock straight up. And it turns out that you can model the height of an object projected straight upwards. If I throw the rock upwards at a velocity of 40 feet per second, and I do it from a height of 6 feet, the height of the object after t seconds is given by this formula. You don't have to remember that formula. That's a formula from physics, and the -16 comes from the force of gravity on the Earth. You'll be given that formula. So if I want to know how high does the rock get, and how long does it take to get there? How long does it take to reach its maximum height? Now, we're actually throwing the rock straight up, and then when it reaches its highest height, it comes straight back down. So I'd have to kind of step back so it didn't hit me on the top of the head. But if I draw a picture of this over time, it's going to, if this is my height, how high the rock is over time, my y-intercept here is 6. So the height of the rock is starting here at 6 feet. It's going to go up to its highest height, and then it's going to come right back down and hit the ground again. I am not throwing the rock in a curve like that. I'm throwing it straight up and straight down. But stretched out over time, the model is a nice parabola. And that's because we have a quadratic equation with a negative coefficient on the t-squared, which gives me a downward facing parabola, exactly as we see in the picture. So when the problem is asking me how high does the rock go and how long does it take to reach that maximum height? It's saying find the vertex, this point right here. Go ahead and write the formula for the vertex. You need to memorize that formula, and then find t and find h of t. And then we'll look back at the problem. All right, maximum of a quadratic means vertex. And the vertex formula is negative b over 2a and f of negative b over 2a. In this case, we're going to be using h of t. So to find t, the time, that's the negative b over 2a. That's the independent variable. So a is negative 16, b is 40. So negative b over 2a is negative 40 over 2 times negative 16. And be careful if you plug this in your calculator. If you plug in negative 40 times 2 times negative 16, it's going, 2 divided by negative 2, it's going to divide and get negative 20, and then it's going to multiply that by negative 16 and give you a much too large number. So if you use your calculator, you have to be sure to put parentheses here. But I'm just going to go ahead and mentally do that part. And using my calculator, 40 divided by 32 is 1.25, so 1 1/4 seconds. And I know that it's seconds because this is the independent variable, the t, and the units on that are seconds. Then to find how high it actually goes, the height, that highest height, I'm going to find h of 1.25. So I can just plug that in place of the t. And I use my calculator to evaluate that. And I get 31. So the highest height that I can throw that rock is 31 feet. What I'm trying to show you here is that if you have a quadratic function, whether you came up with it using information given in the problem, or whether you were just given the function, if you want to find the maximum or the minimum, depending upon which way the parabola is facing, of a quadratic function, all that is the vertex. Find the vertex and memorize that formula, negative b over 2a, and then to find the dependent variable, plug it into the given function.